keeping our overall goal of finding the sum of an infinite series, we have another test that we'll get to use, and it's called the nth term test. At the end of this lesson, you'll be able to determine whether an infinite series converges or diverges using the nth term test. Right? Again, this is just a tool. It won't work for every problem. It's just one that we can try to use when we're trying to decide whether a sum converges or diverges, whether we can get an answer or not. Okay, if the sum of the series, so means the sum of the series, if the sum of the series converges, which means if we get an answer for the sum, like 4 or 2/3 or whatever, then it must be true. So if the sum converges, it must be true that the sequence approaches 0. So it has, I'm just going to even say the limit of the sequence approaches 0 as n approaches infinity. So the limit of the sequence has to be 0. All right. If that doesn't happen, if the limit does not equal 0, then the sum of the series diverges. Okay. But unfortunately, just because the sequence has a limit of 0, this does not guarantee that the sequence has a sum. So if we're using the nth term test and we're looking at to see if the limit of the sequence is equal to 0, if it doesn't equal 0, we'll automatically get that the sum diverges. If we get equal 0, then we are actually going to call that test inconclusive. It didn't show us anything, so we're going to need to try to find something else, because it doesn't mean it automatically converges. It just is, just like if we get 0 over 0 or infinity over infinity, that test did not work. All right, so let's try some examples. Let's find the sum of the series sine of n, which means we'd plug in sine of 0, then we plug in sine of 1 and sine of 2, and we'd be adding those terms together. What we would like to do, first of all, the nth term test is saying if I found the limit as n approaches infinity of the actual sequence that's representing the series of the sine of n, we would like to figure out what is going on with this. Now, if you recall with the sine of n, the sine constantly toggles back and forth between 1 and -1. So as n approaches infinity, this limit does not exist. So since the limit does not equal 0, we can say that the sum diverges. We're not going to get an answer for the sum of this series. All right, another example, it says to find the sum. We've got going from 0 to infinity of n over 2n plus 1. If the sum converges, that would mean my limit of the actual sequence would equal 0. So we're going to find the limit as n approaches infinity of the actual sequence, so of n over 2n plus 1. So now we're going to be pretty much using our tools from 11.1 and from L'Hopital's rule. If I plugged in infinity, I would get infinity over infinity, which means that I am going to apply L'Hopital's rule. And if I do that, I'll have the limit as n approaches infinity of 1 over 2, so that limit will equal 1/2. And since the limit does not equal 1, we can say that this sum diverges. If I added all the numbers together in that sequence, it would not end up heading towards any specific number. All right, let's sneak down to example 8. We would like to find the sum of the series n equals 1 to infinity of the natural log of n over n plus 1. Please remember, for using the nth term test, we're going to be finding the limit as n approaches infinity of the natural log of n over n plus 1. So first thing we'll always try to do is plug in infinity, and if I do that, I'll get the natural log of infinity over infinity, which would just be indeterminate, so that allows me to use L'Hopital's rule. All right, and if I do that, we'll get the limit as n approaches infinity of the natural log of, we'll take the derivative of what's inside of the fraction, we'll get 1 over 1. So we'll end up getting the natural log of 1, and the natural log of 1 is equal to 0. So if we get a limit of 0, that doesn't mean, for sure it doesn't diverge, but we are not sure if it converges or diverges. So when we get a sum of 0, that means that nth term test is inconclusive, which means we need to try something else. And so far we don't have anything else to try because this is not a geometric series. So the only other thing that we've learned so far is partial sums, so we get to do partial sums. Alrighty, so if I do this, I'm just going to start writing a few terms of the sequence. If I were to plug in 1, I get the natural log of 1/2. If I plugged in 2, I get the natural log of 2/3. If I plug in 3, I'll get the natural log of 3/4. If I plug in 4, I'll get the natural log of 4/5. And what we're going to be trying to do is partial sums with this one. So if I take sum 1, it's just the natural log of 1/2. And if I take the natural log of 1/2, it's going to be negative 0.693. And then I'll do the second sum, which would be ln 1/2 plus ln 2/3. And if I do that, I'm going to get negative 1.099. Then I'll do the sum, 3 sums, and ln of 1/2 plus ln of 2/3 plus the natural log of 3/4. And if I do that, I'll get negative 1.38. And if I do the fourth sum, we'll do ln of 1/2 plus ln of 2/3 plus ln of 3/4 plus the natural log of 5/6. Oh, excuse me, that should be 4/5. Sorry about that. And that will equal negative 1.609. And if I kept going and kept going, we could actually probably go up to 6 or 7 and actually see this. This number is continuing to get just a little bit bigger every time, so it's becoming a little bit bigger of a negative number. So actually, as I keep going, and especially if I tested a few more of those partial sums, it's actually going to be approaching negative infinity very slowly, but still it is approaching negative infinity. So this sum does not, since it's approaching negative infinity, this sum will diverge. Alrighty, so hopefully now you are familiar with the nth term test and can use it to decide whether a series converges or diverges.